In our last video, we talked about air masses, which is a mass of air with similar properties of both temperature and humidity. Related to air masses is a front. Now, a front is simply a transition zone between two air masses of different densities. I'll give you a good example here. In this figure, we have a continental polar air mass right here. Down here you have a maritime tropical air mass. The boundary between the two is a front. Likewise, we have a maritime polar air mass over here. The boundary between the two is a front. Now there are four basic types of fronts that we see here in our key for this figure. Cold fronts, warm fronts, stationary fronts, and occluded fronts. We'll start talking about the simplest, and that is the stationary front. But before I do, let's talk about the basic ways you can tell when you have a front. When you have a front then you'll see it on a chart as a sharp change in temperature, a sharp change in dew point, a shift in wind direction, a sharp change in pressure, and then you'll have significant clouds and precipitation along that front. And we'll see these again in just a few slides. Let's begin with a stationary front. Here you have a continental polar air mass and maritime polar air mass, so the boundary between these is a front. But if this front is not moving, it's stationary. So stationary front, of course, would be a front with no movement. The way we indicate this is a line with alternating red circles and blue triangles. Now, the blue triangles indicate that's the direction the colder air is trying to move. So in this case, the colder air is trying to move to the southwest. And the red circles are pointing the direction the warmer air wants to move. So in this case, the warmer air wants to move to the northeast. Okay. Quick note about the winds. The winds are going to be in opposite directions, but they'll be parallel. So on the cold side, wind is moving to the north, basically, and on the warmer side, air is moving to the south. What kind of weather can you expect with a warm front? There's a lot of different things that can happen. The weather is quite variable, so we do not have any very specific set of weather phenomena to look out for with a stationary front. The next one to discuss is the cold front, where you have a colder air mass that is moving forward and overtaking a warmer air mass. We indicate a cold front using a blue line with blue triangles pointing in the direction of the front's movement. With a cold front, we often have vertically developed cloud formations, and I will show you that in a couple slides. I'll show you why we have vertical development. And so since there's vertical development, there's a lot of potential for thunderstorms and even squall lines along that cold front. Remember those identification points we talked about a few slides ago? Here's a close-up view of the cold front. What we see is a sharp change in temperature. Ahead of this front, we see temperatures of 50, 56, 49, 58. So 50 and above, roughly. Whereas behind, the temperatures have dropped to 39, 37, 36, so on. Sharp change in dew point. Before we had 50, 48, 49, where it drops to 36, 37, 30. You can see a huge change in the dew point, or the humidity. Change in wind direction. Notice the general wind pattern ahead of the front is from the southwest, whereas the general wind pattern behind the front is from the northwest, going to the southeast. Sharp changes in pressure. In this figure, you can look at the pressure. There's not a huge change in pressure, but some. There's a drop in pressure. And then the clouds and precipitation. The green region indicates the region where you can expect lots of rain. And what do we see? Rain showers, thunderstorms, actual rain, and sometimes even snow. Now let's talk a little bit more about these cloud developments and the precipitation. This is what a cold front would look like if you could actually see the difference between cold and warm air. As cold air moves along, cold air is more dense than the warm air, and so it will dig down and underneath the warm air. So the warm air is then pushed upwards ahead of the cold air. This is why we have a lot of vertical development, vertical cloud development with a cold front. And since it's a vertical development, that gives a lot of chance for thunderstorms and that type of precipitation. Here's a radar image of a cold front. Very typical to see these lines of thunderstorms along a cold front. And if it's a very consistent line, kind of like what you see in this region here that I just drew on, we often call that a squall line. You can also have cold fronts coming from other directions, from directions that are uncommon. We usually see cold fronts coming from the from the northwest down to the southeast, like we saw back in this figure here, from the northwest to the southeast. But sometimes they can come from different directions. For instance, if you have a high pressure here, winds are going clockwise, brings maritime polar air onto the continent. This would be an example of what we call a backdoor front, coming from the opposite direction. In your textbook, Table 8.2 talks about a lot of the different changes in weather variables that you could expect with a cold front. Now let's talk about a warm front. A warm front indicates where you have warm, moist air, often moist. Something that doesn't have to be moist. You could have continental tropical air. But you have warm air that is overtaking a mass of colder air. So we indicate that with a red line with red semicircles pointing in the direction of the front's movement. Often with a warm front we get more horizontal cloud development, which means that instead of having thunderstorms and squall lines, you're going to have more consistent, steady, perpetual rain. So here's what we see. Again, we can see a lot of those same transitions. You change from colder temperatures in the low 30s to warmer where you're in the upper 40s, lower 50s. Changes in temperature, we change from dew points in the low 30s, high 20s to dew points in the mid to high 40s. Wind direction. Ahead of the front, again, notice in this case, wind is coming from the southeast. And then behind the front, winds are coming from the southwest. And then again, your precipitation, you're going to look at more steady precipitation. You're going to have snowfall, you're going to have freezing rain, and sleet. And then you can also have lots of fog will also happen during a warm front. Here's what a warm front would look like if you could actually see it. As the warm air overtakes the cold air, warm air rises, so it will just move right up on top of the cold air as the cold air moves forward. So the warm air moves forward up this slanted slope that you see here, and as such, it's more of a horizontally developed cloud formations. So you get your stratus, your nimbostratus, your altostratus, cirrostratus. So you get more of these horizontally formed clouds, which gives you not showers, not thunderstorms, but instead gives you these different steady rainfall, steady precipitation. Again, Table 8.3 in your textbook talks more about warm fronts. Now let's talk a little bit about the last one, which is an occluded front, which is the case where a cold front catches up to and overtakes a warm front. We indicate this with a purple line with alternating purple triangles and purple semicircles. So here is a cold front catching up to a warm front, and then as it catches up, you end up with an occlusion. There is your occluded front right there, where the moment that your cold front meets up with the warm front, you've got an occlusion. But what happens from here is going to depend on the temperature of the air. In this example, we have very cold air that's overtaking, that's cold but not as cold air, so cool air. As such, the warm air, in either case, is being forced upwards, and the very cold air is going to dig underneath while the somewhat cold air remains on top. And so basically the warm front rides up on top of the cold front. This is what you would get in this example. This is what we call a cold occlusion. Basically what you would expect is you have cold temperatures, and then you get the precipitation of a warm front followed by the precipitation of a cold front. So going from steady to showers, and then that's followed with a drop in temperature. This would be a good example of when a cold front overtakes a warm front in the middle of the Great Plains, because then you'll have your continental polar air mass overtaking your maritime tropical air mass, which would be overtaking, this could be either continental polar or maritime polar, one or the other, just not quite as cold. Now, what would happen if instead we'll switch things around and the colder air is now ahead and the cooler air is behind? The cold front has cool air that's not as cold as it was before. Well, then the cold air remains down below and the cooler air is going to ride up on top of the extremely cold air. So in this case, the cold front rides up on top of the warm front. Very similar situation. You're going to have lots of showers here with a lot of your steady precipitation over here. Same situation as before, but the temperature actually warms up a little bit. It'll still be nice and cool, but it'll be a little bit warmer than it was before. In either case, your warm air is being pushed upwards and away from the surface. So here's a good example of where you would see a warm occlusion, where you have maritime polar air meeting up with some warmer air mass. Could be continental tropical, could be maritime tropical, either one, which is overtaking a cold continental polar air mass. So this is a good example for an occluded front. Again, table 8.4 in your textbook discusses more of the weather variables involved with occluded fronts. And so those are the four different fronts that we talked about: stationary fronts, cold fronts, warm fronts, and then the one where the cold front overtakes the warm front, known as an occluded front.